1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground.
We interrupt our program to bring you this important message.
You don't want to do that.
Hello, Mr. Gutahin. Welcome to my garage.
In linear motion, momentum is simple. You apply a force in a direction, and momentum increases in that direction.
In rotational motion, things are more complicated. There's obviously momentum in this wheel, or it wouldn't keep spinning. But in what direction is the momentum? This is the wheel I'm going to use to do hoodoo magic. But before I do, I would like to discuss the existing torque present. This wheel is hanging here. There's a force from gravity applied because of the weight of the wheel. The torque is equal to this force times its displacement from the hanging point. Can you guess what would happen if I let go of the wheel? Let's see. Whoa. I know what you're thinking, and don't worry, it's almost hoodoo magic time. But first, let's think about earlier, when I dropped the wheel. Do you remember that? I know it was pretty cool. But, in what direction was the angular momentum? When I dropped the wheel, it rotated from the torque like that. Let's use the right-hand rule. The rotation was in that direction. So, the angular momentum is in the same direction of the torque at me. I know you're very excited for hoodoo magic time, but there's nothing I like more than hearing myself talk. Except watching myself kick buckets. It's hoodoo magic time. Before we get started, I have to address one important topic. The camera angle has obviously changed. If you didn't notice, you aren't paying enough attention. The camera was sitting on my mother's car. Apparently she needed it, so she took it away. Now you're sitting on top of a trash can. You're welcome. Let's talk science so we can understand the hoodoo magic. Remember when I dropped this wheel? It was pretty cool. Remember when we talked about the torque and angular momentum in this wheel? Also pretty cool. If you don't, it was that way, using the right-hand rule, towards the back of my garage. I trust that you all understand the torque and angular momentum from dropping the wheel. If you don't, go back and rewatch the video and pay more attention. What happens whenever we add another torque and more angular momentum to this system by spinning it in this direction? The torque, using the right-hand rule, is towards you, the camera, and the angular momentum. This angular momentum is going to hold the wheel up, keeping it from falling like it did last time. However, we must not forget about the torque from before. When we drop the wheel, a torque is created in that direction. Spinning the wheel doesn't get rid of this torque, it simply makes the wheel stay upright. So, that same torque, dropping, is going to push the wheel in that direction, causing it to rotate. Yeah.
If you have a problem, if no one else can help, and if you can find them, maybe you can hire the A-Team.